Assalamu alaikum students. Welcome to our online chemistry class. Hope all of you are fine by the grace of Almighty Allah. Today at first I will discuss about a very easy topics of chapter 6, which is percent composition. What is percent composition? The gram measurement of an element present in 100 gram of any compound is known as the percent composition of that element. And that means if a compound or molecule have two or more constituent elements, that means a compound is made of two or more different elements, atoms, then the amount of these atoms of each element in 100 gram of that compound is known as the percent composition of that element. And the molecular formula is the main source to determine the percent composition of any element in a compound. There is a formula in your book for calculating the percentage composition of any element. You can also use the unitary method, but the formula is the percent composition of an element in a compound is equal to atomic mass. At first you have to take the atomic mass of element and then multiply by number of atoms of that element and multiplied by 100 and then divide by the molecular mass of that compound. And it will be more clear to you if we practice by solving some problems. Okay, then at first problem, the first problem is what are the percent composition of elements in HCl. HCl is a very simple compound. That means considering 100, we know in HCl contains hydrogen and chlorine atom in it, and if considering 100 gram HCl, now we have to calculate, we have to find out how much hydrogen and how much chlorine are present in it. Okay, and for that at first you have to find out the molecular formula and the molecular mass. Molecular formula is given there. So the molecular mass of or molar mass of HCl is atomic mass of hydrogen is 1 and the chlorine is 35.5. That means 36.5. Molar mass or molecular mass of HCl is 36.5. Now we have to calculate the percent composition of hydrogen and then percent composition of chlorine. Percent composition of hydrogen is equal to, look at this formula. Okay, atomic mass of the element, that means atomic mass, we have to take the atomic mass of hydrogen 1 and the total number of hydrogen atoms. The hydrogen atom in HCl is 1 and then multiplied by 100 and divided by molecular mass of HCl, that means 36.5, and you have to calculate it by your own. I am taking from your book. The answer is 2.74 gram. Okay, since in hydrogen, since in HCl only hydrogen and chlorine atoms are present, so if we subtract the percent composition of hydrogen from 100%, then we can easily get the percentage of chlorine. So percentage of chlorine, 100 minus 2.74 is equal to 97.26%. And we can use an alternative way also. This way, percent composition like the atomic mass of chlorine by number of chlorine 1 into 100 and molecular mass and molar mass of HCl is 36.5, and the same value will be found. Okay, this is the procedure how we can get the percent composition of any element from molecular formula. Okay, and then another problem, we can practice another problem. Second one, find out the percent composition of hydrogen, sulfur and oxygen in sulfuric acid. And similarly, at first we have to calculate the molecular mass of sulfuric acid. Hydrogen 1 into 2, sulfur 32, oxygen 16 into 4, and that is 98. So the molecular mass of sulfuric acid is 98. Now the percentage of hydrogen 1 into 2, number of atom 2, multiplied by 100 divided by 98. Okay, then percentage of sulfur molecular atomic mass of sulfur is 32, number of atom is 1, multiplied by 100 divided by 98. And of oxygen, the atomic mass of oxygen is 16, number of atom is 4, 100 divided by 98 is equal to, and this is also given in your book. The answer is 2.% here, 32.65%, and oxygen is 65.3. Very easy mathematical problem, very easy. But in MCQ and CQ, for your exam paper, questions may come, and you have to practice using different types of compounds. Now our topics is molecular formula and empirical formula, and by using the percent composition of any element, how can we find out the molecular formula and empirical formula of that compound? All of you know that what is symbol, what is formula. The formula is the short expression of any molecule or compound. And in chemistry, there are different types of formula. A molecule or compound has mainly 3 types of formulas. One is molecular formula, and another is empirical formula, and then the structural formula. What is structural formula? Here a molecule of compound propene is here, and this is the structural formula of propene. Propene is organic compound. This is the structural formula. That means the formula that express a molecule through symbols of atoms and bonds of atoms. That means show the organization or arrangement of atoms in it. This formula is considered as structural formula. Here all the bond, carbon, hydrogen, carbon, carbon, all the bonds are shown in this formula. Okay, and you will learn about the structural formula more in higher classes. Okay, then what is molecular formula? Molecular formula is the actual formula of any chemical compound, the regular formula. Okay, molecular formula tells us how many atoms of each constituent element are present in a compound. How many atoms of each element are in a compound. Look at this compound, propene. Here in propene, two atoms, carbon and hydrogen, two elements, carbon and hydrogens are present. Okay, then carbon. How many carbons are present in propene? 1, 2 and 3. Then put 3. And how many hydrogen? 1, 2, 3, 4, 5, 6. 6 hydrogen. 6 hydrogen. This is the molecular formula of propene. This is the structural formula of propene. This is the molecular formula of propene. Okay, from this we can easily understand the actual number of carbon, which is 3. We get the information about the actual number of hydrogen atom, which is 6. Okay, then what is empirical formula? What is empirical formula? Empirical formula tells us the simplest or most reduced ratio. It's a ratio. The simplest or most reduced ratio of atoms in a compound. That means it's just a ratio. We didn't get any information about the actual number of atoms. Okay, from the empirical formula. Okay, then how we can get empirical formula from molecular formula? Okay, using molecular formula, how can we find out the empirical formula? Let's see. This is propene. Okay, and if we take the ratio of carbon and hydrogen atom, then we can write like that 3:6. 3:6. Okay, now we have to think what is the largest number by which we can divide both of these number. And the largest number of is 3. If we divide this both number by 3, then we will get a whole number. 1:2. Okay, and this is the simplest, this is the most reduced, simplest form of this ratio, 3:6. And then we can use this ratio to determine the empirical formula. Okay, we have to write the empirical formula based on this simplest ratio. Okay, and then this will be carbon 1, and the number 1 is not needed to put it in any formula. Okay, and so carbon and hydrogen 2, and this is the empirical formula of propene. That means this is the structural formula of propene, this is the molecular formula of propene, and this is the empirical formula of propene. But some molecular formulas we cannot simplify them anymore. Okay, and for example, water molecule. Okay, H2O, and C3H8. This is organic compound H2O, water molecule. For this, the ratio is 2:1, and carbon hydrogen ratio is 3:8, and there is no whole number. By which we can divide the both and get the whole number. Okay, that's why if the ratios of atoms in a molecular formula, we cannot simplify it anymore, then the molecular formula is the same as the empirical formula. Okay, for this type of compounds, empirical formula is the same as the molecular formula. That means H2O is the molecular formula as well as empirical formula of water, and C3H8 is the both empirical formula and molecular formula for this compound. Okay, and sometimes many molecules, many compounds with different molecule or compounds with different molecular formula can have the same empirical formula. Okay, molecular formula is different, but empirical formulas are same. Okay, then suppose for propene, the molecular formula is this, and the empirical formula is CH2. Okay, and for C2H4, this is ethene. C4H8, this is butene. C5H10. Okay, this is pentene. These all are organic compounds. For these compounds, the empirical formula is the same, CH2. That means they are different molecules, different compounds with different molecular formula, but for all of these compounds, the empirical formula is CH2. That's all for today, student. Assalamu alaikum.